Saxon's Calculus Lesson 28 is about change of base and then logarithmic inequalities. So we know that in log statements, we rearrange things to change them from their log form to their exponent form. And they also remind you that when you are multiplying something in front of a log statement, it's becoming the exponent. So if you are given log base 4 of 15, we want to memorize, and it's super simple, a quick and easy way to do this without having to rearrange it particularly and then try to manipulate it on the calculator. So here is how this always works. You will take the log of whatever the large number is, and you will divide it by the log of the base number, whatever it is. And that will always give you very quickly what the decimal will be, or depending if they want it left in fraction form or not. So example 1 says log base 4 of x. So here's the problem with trying to rearrange it. It would be like 4 to the y power equals x. Well, then I still have two unknowns. But if I follow this, I know that what I'm doing is log of the large thing, which is x, dividing by log of the base number, which is 4. So there's nothing I can really do with log of x, but log of 4 on the calculator turns into 0.602. So I can just box that as the answer the best I can get there. How about, for example, 2, log 13 of y. So we're going to do log of y, the large number, divided by log of 13, the base number. And that's going to become the decimal 2.56. Now, when I looked at the answer key, they listed it not as log y over 2.56, but natural log y over 2.56. Does it matter if the book or the instructions don't tell me which one to use? Nope. And so they said this time we're going to use e as the base, but we can still use our log. So either way, it's going to be acceptable. On example 3, use the calculator to evaluate 4 log of 15.6 plus 5 log base 4 of 7. So the last time we looked at logs, we needed them to have the same base. Well, this is a 15, this is a 4. There's no relationship between those two. So I am better off to do this fractional shortcut and solve. So we're going to do log of our large number, which is 6. However, the 4, which was multiplying in front, I'm looking to see. Oh, guess they're going to come back to that. All right, we're just going to finish that. Then log of the base, which is 15, plus, and again, I'm going to do the same thing with 5. I'm going to ignore it for the moment. Log of 7 divided by log of 4. Now, both of those can be turned into decimals. So on the calculator, log of 6 divided by log of 15 should come out 0.662 or something close to that. And then log of 7 divided by log of 4 should give you something close to 1.404. So now we go back and we do 4 times the 0.662 plus 5 times the 1.404, and you should get a final answer then of 9.668. Example 4, log base b of 47 equals 17, find b. Now in this case, I would just do the rearranging and say b to the 17th equals 47. And then how do I change this b to the 17th over to b to the 1st? Well, I do the 17th root, and if I do it on one side, I better do it on the other. So now b equals whatever the calculator spits out is the 17th root of 47. And again, you have to play with your calculator to figure out which order it wants it, but you should be getting an answer very close to 1.254. Now you could try to do the log base 47 over the log base b. But you see, once you put that to log base b in the denominator, it's not helping you. That's why the rearrange is much better and faster there. Part B, the log inequalities. I'm going to jump over to example 5. So it gives us log base 4 for x minus 2 is less than 3. So this is where we're talking inequalities. You've got greater thans or less than rather than equal signs in here. Now, with absolute values, we learned that we had two different versions that we needed to do to answer the problem. This is sort of similar in the fact that we are going to solve x minus 2 in a relationship with the 3, but we also have to solve what this part is. It can't be negative. Remember, log statements can't have negatives. So the other part I have to solve is that this has to be greater than 0 as part of my answer. Now, here is the key and the reason I didn't finish this. When my base is a whole number, it's opposite of the way I wish to think it. I will flip this symbol as part of my solution. So we're actually going to be solving x minus 2 is greater than 3. This isn't totally the way the book does it. Did I miss? Oh, I did. I can't just do this with 3. I do have to take the 4 into account here. That's my fault. I do need to fix this as 4 cubed before I can do the solution. Okay, now we're back on track. So x minus 2 is greater than 4 times 4 is 16 times 4 is 64. So x is greater than 66 when I, just a second, I changed the symbol because it was the, oh, I don't mean in this one. Hang on. Oh! I even wrote the note in the book. Let me leave it this way for a split second. X is greater than 2. Yes. Okay, so when I write those together, x has to be greater than 2. So I'm writing it backwards. So the open sign has to be here. And then it should be less than 66. All right, I'm going to pause this while I figure out what flipped. Yes, it just hit me exactly what I was saying. I did 2 steps simultaneously, and that threw me off. Okay. If I do what I did here, you're absolutely fine. If I start with the rearranging to get to my 4 cubed base to the exponent, then this, because this is a whole number, wants to be greater than x minus 2 that I'm solving. So that's where, when I wrote this one first, I didn't need to flip the sign, but I'm used to doing it this way, and that's my reminder to myself. When my base is a whole number, I change that sign. Now, in the next example, it's a fractional base. So this one, and I'll do it my original way and not throw myself off, 1/3 x minus 6 is greater than 4. Okay, so we're going to do base of 1/3 to the exponent of 4, and instead of equaling, it's going to be, so I don't flip the symbol when it's a fractional base. I keep it greater than. And then I solve it the same way. So 1 to the 4th is 1, 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is, I want to say 81. But am I doing that? No, it is 81. Okay, but that's 4 times. And then greater than x minus 6. So I'm going to add the 6. So x should be less than, just keeping the symbol the right way toward the x, 6 and 1 over 81. Did they make that? Nope, they left it at 6 and 1 over 81. And then the other way is still the x minus 6 has to be greater than the 0 to avoid any negatives. So x has to be greater than 6. And when I write this all together, x in the middle, the 6 is the smaller number, so I need to have the greater than symbol that way, and then less than the 6 to the 1 over 81. So hopefully my little boo-boo there in the last example didn't mess you up too badly.